So everyone, please welcome Steve Lutz, who currently works in computer security and has past experience with corporate projects in physics and engineering on a variety of incredibly interesting topics. He also is involved in propulsion and works with several well-known theoreticians and experimentalists that get regular mentions in our event. So he's going to be talking today, at least in part, on some of his observations on superconductive gravity modification from working with Podkletnov, Modanese, and Poher. So welcome, sir, and feel free to go right ahead.
Thank you. My talk is going to be mostly non-technical, I would think, or medium technical. I appreciate the fact that Remy's on, Remy Cornwall, because he can backstop some of the things I think or speculate about. But I'll just go into I'm actually using this new iPad, and it follows you around if you notice. It's weird. Wherever I go, it just follows me. So I'll just give a little brief background how I got involved in this space. I started a company overseas that was researching novel methods of fabricating group 3,5 nitrides in the semiconductor space. So that would be your gallium nitride, your indium gallium nitride, et cetera, right? Which is a big thing in the space now. I mean, my house mostly is GaN lighting, and my iPhone charger is a GaN MOSFET, which is tiny and very powerful. So it's a great material system. Anyway, I got involved in the, the propulsion space simply by reading papers that Professor Modanese, Giovanni Modanese, had published, along with Evgeny Podkletnov, a Russian-born scientist. And in those discussions, back and forth with them, I started having discussions mostly with Evgeny about his experiments. And then through that, I think it was Giovanni introduced me to Dr. Claude Poher over in France. Working with the two groups, I noticed a couple of things. One, obviously they're both working with the same material systems. This was YBCO superconductors, and both required liquid nitrogen cooling. We'll call it LN2 for now. One thing I noticed when talking with Evgeny, he was using very high pulses of electricity and getting these very dramatic effects. There was a beam that would, a force beam that he could measure. They did measure the speed of this thing using a couple of rubidium clocks. And let's see, what was interesting about it. It was a mono disc of material. He described crystallinity to me being, I would say, high order polycrystalline, not quite monocrystalline, but decent quality. And he told me that he was getting a self-collimating beam out of it, which I thought was rather interesting, out of a single piece of material. So anyway, back over to Claude Poher, I started actually working with him because he had some interesting applications. What he did was he went to thin films. I'm going to call them low order polycrystalline. He was making himself, and he would stack them. I think when I was working with him, he was up to maybe 12 layers. All of this is published, so I'm not violating any non-disclosure agreements that I have with him. And he was getting, he got the voltage down, I think, to 1,000 volts, rather than Evgeny was using 1.5 million to, I think, up as high as 3 million volts at some point. And he was getting a similar effect, but it was not self-collimating, it was conical. It kind of fell off pretty quick. But he had measured the propulsion from it. It was quite high. He showed me a chart comparing different rocket motors, scramjets, ramjets, and so forth. You had this graph. And then as far as his measurements were concerned, it was way up above anything that we currently use in the rocket space or whatever. So very interesting. One of the things I was tasked with was to work on the cooling budget, the LN2 budget, to see if we had a side application we were working on, and there was a cooling budget involved. So I got in touch with some companies that build such equipment, back and forth, getting budgets. It turned out the budget was quite high. Cost of that cooling equipment is high, doable, but bulky and big. Nothing you could certainly fly around with. But this was a ground-based application we were working on. That led me to looking at raising the temperature of the superconductor. So I started looking into metamaterials, which looked very promising, that were offering potentially superconducting properties. And that was interesting as well. I think at that point, I reached out to a couple of different research teams that were working on it, and then I had to leave the project for other reasons, more in the information security space, which is where I normally reside. Half the time, the other half the time, I'm in the semiconductor space and material science. But anyway, one thing that he said, I asked him a question about these craft. You see them zipping around and whatever. We've seen the videos I think they've released. And I asked him about, I kind of felt foolish when I asked him, but I said, I used the Star Trek term inertial dampening or whatever. I was like, how do they get away with this? How does the craft survive it? And if there's any, say occupants, for example, biologics, how would they survive it, with these G-forces that are happening? And he kind of said, well, I'll show you how it works. And he started doing some math. And then he pointed me to the quantum locking that Tel Aviv University had demonstrated. And he said, it's similar to that. It's related to that, but it's not the same thing. It doesn't involve magnets or whatever. So I kind of, that stuck in my head. I left the project, but I still kept thinking about, as an engineer, I kept thinking, how would you establish a field like that? And I built a craft in my mind. And, it's a shape, maybe it's a sphere. In this case, I did like a sort of a saucer or whatever. And I started looking at the material. I said, okay, let's say magically we have metamaterials that are room temperature superconductors. Great. Now, how would you, I already know the thruster part of it. That's pretty well, they're pretty far along with that. But I was like, how would you create this field and sustain it in the craft? And I thought about the Tel Aviv stuff, and I was like, well, okay. First thing I thought of was, took me back to the group 3,5 nitride research, right? So in 3,5 nitrides, you work with C-plane, which is normal. That's what I was working with because I was on a low budget. Then you can work with M-plane, which is like semi-orbital. And then if you got a real big budget like military, you would work with the P-plane, which is non-orbital planes. And I knew I had discussions with the chief scientist over at DARPA, the Defense Advanced, well, I think they call themselves ARPA now. But we were talking about these problems, and it became very clear that if you could grow the materials, it's a hexagonal structure, GaN or InGaN, similar to zinc oxide, if you're familiar. So if you grow it C-plane, it's kind of flat. If you grow it M-plane, it's at an angle. So you have these crystals growing, and they're rather delicate. If you heat them too much when you're growing them, they'll just kind of crumble. And then the hardest one was the P-plane, the non-orbital. But as you move from orbital to semi-orbital to non-orbital, you get amazing performance increases out of the material, right? So the brass ring in the nitride space is non-orbital. And you can Google it, and there's a lot of papers on it. But I started applying that thinking to this hypothetical metamaterial I had in my head. So I put it non-orbital on the shell of this craft. So the craft has a surface, and I've got this magic metamaterial that hasn't been invented yet, and it's in a non-orbital state. It's sitting there. So the next thing, I was reading some patents by a gentleman by the name of Levengood. Has anybody, I don't know if anybody's read any of his stuff. He, how did I find him? He was the guy that basically got involved with, there's a researcher, Linda Moulton Howe, and he was investigating these crop circle things. And through an audio recording, I think he was able to reverse engineer to some degree what was going on in those fields. And he built an apparatus. He patented it. Basically, what it did, it was like you had an anode or a cathode, and he would hit it with the DC voltage with a AC ripple superimposed on the DC, which I thought was very interesting. And what would happen was there would be like this self-organizing plasma cascade of ions. And in the middle of that, he would put a variety of different seeds and treat them at different, intensities, and then, measure the output. It was very interesting. The plants, depending on the plant, would grow either 15 to 25% faster, or you could tune it and it would grow at the same rate, but 15 or 25% bigger, more yield. You get more corn, you get more whatever. Anyway, I was thinking about that patent and I was reading it and I thought, what if we took that superconductor metamaterial and we hit it with that same type of energy, right? We hit it with DC to saturate it and then superimposed AC on it and maybe got it to resonate, right, in some way. And the thought I had in my mind was, what if you cranked up the AC portion so that you were in the gigahertz or even terahertz frequency range? And if you did that, would you create standing waves inside of this craft? Would that occur? Like you do with audio, you can do it all the time, standing waves. I used to be an audio engineer and it was a big problem for us with standing waves. So anyway, I thought, what if you did that and you could create this field that Dr. Poher was referring to, which was that related to that quantum locking? Would you get a field that inside you're in the craft and you're basically quantum locked? So you wouldn't feel any inertia if the craft was zigging around or whatever. You probably wouldn't feel gravity fields that are outside it. Basically, this field would stand in for the mass, all the atoms inside and including the skin of the craft. This is my thought anyway. This could all be very way off base. I don't know. So I was playing with that in my head and thinking, okay, maybe that would work. I have to talk to somebody who's well-trained in physics to see if there's any merit to those thoughts. And then later I was working on hypersonics. I was looking at hypersonic aircraft. I had a mutual friend with Mark Lewis over at the Department of Defense. They're heavily looking into, obviously hypersonics. And I started studying the problem, and you see this on the skin of the craft. You have crazy things happen at hypersonic speeds. It's chemistry. It's like, for example, if you have a hypersonic aircraft that's going through the atmosphere and it hits a pollution layer, that changes a lot. You have to account for that. You have to adjust for it. At the skin of the craft, there's some crazy physics happening. So I thought about that, and I was looking at using fractal mathematics to model that problem, which after I Googled it, the Chinese are already doing exactly that. So I was a little late to the game. However, I thought about my fictional craft, right, with that fictional metamaterial, with that field, the standing waves inside, and everybody's all comfy inside, not subject to inertial, movement or whatever. And I started thinking about the skin of that craft and the field, right? My non-orbital metamaterial. Obviously, from the skin in, you have this nice standing wave thing that you've put together. But the outside of that is going to be, because it's non-orbital, for example, you're going to have whatever this field is going to be projecting out a short way off the skin of the craft. And the thought occurred to me, how would that change the drag coefficient of this thing? In other words, you have, let's say we're in atmosphere, you're going through nitrogen, oxygen, humidity, whatever. When it comes in contact, would that change the drag coefficient? The answer is I have no idea, but it certainly would change it. If you have, it might pin, right, what Remy just said, it might pin the air around it to some degree, or who knows, right? But it's like a half field. It's not a standing wave at this point. It's going to be like this. I thought of it in my mind as like hairs or cilia coming off of energy, right? Coming off the skin. Probably not a long distance, depending on the intensity of the field. The other thing that came to mind, I was thinking about it, is when let's say this field is standing in for the mass of the craft, and the mass would be the material itself, all the atmosphere inside, if there's any beings in there, people or whatever, everything. Is there a relationship between the amount of energy you need to establish that field and the total mass of the craft? Or is it independent? It's just a volumetric thing. You don't care if you've got lead in there or if you've got aluminum or whatever. I don't know, right? But the thought, I was trying to wrestle with it in my mind. Let's see what happened next. So I thought, okay, that's a question. If you can create this field, would it impact the drag coefficient of the craft? The answer is maybe, who knows? The next thing I thought of, I was rereading the old stuff with Einstein's work. And, everybody knows that, you take mass, you accelerate it, and it comes near light speed, approaches light speed, the mass becomes infinite. There's a lot of debate about why, what's the mechanism? And I thought in my head, what if, just like you take a ferrous material and run it through a magnetic field and it picks up energy, right? Like they had this problem when they first came out with steam engines, and they would run them and the axles would become energized because it's, moving through a magnetic field, and they solved the problem. But that idea, only you have this field that's standing in for the mass. And so as, let's say the field is standing in for it, I call it a substitution, from a mass substitution kind of thing, the field itself, as you approach light speed, instead of the mass increasing, it will pick up energy from the ether, or whatever we're calling you guys would know the terms better than me, but it might pick up energy, and your only problem at that point would be bleeding off that energy, but your mass problem might not be there. So you might even be able to approach or hit light speed without the headaches of infinite mass, right? Maybe, I don't know. It's another idea. But the thought occurred to me, if this thing is standing in, if it's not only like doing this quantum locking thing for the craft and the occupants or whatever, but if it also might stand in for the mass, which I kind of skipped ahead a little bit, but I started thinking about it. If you had this craft and you energized it and you put a mouse in it, you shook it around, the mouse would just sit there, right? It would be almost like a ZOG environment, right? And let's see, so yeah. So if you have this thing and this field is established, right, you would feel like you're weightless inside. So I did talk to Dr. Poher about this problem. And basically what you could do is set up a field within a field. And he showed me how you would do it. Those thrusters we're talking about, you would just have a 1G down thrust. Let's say you pick the floor of the thing, and you'd have this thing constantly going. It would be like a magnetic field. It would circle around, and you'd constantly have this 1G. So you could create an atmosphere inside the craft where you had this constant 1G, no matter which orientation it had. You'd always be, stuck to the floor. That was interesting. But the thing I thought was, if you establish this craft with this field and it's standing in for the mass temporarily while the field is up, you would be able to, let's say you had a 10,000 kilo craft, right? And then you turn on the field and it might turn into a 10-gram craft, let's just say. And at that point, how much thrust do you really need? I mean, Remy could do a quick calculation. You could go up to it with a baseball bat, hit it, and probably knock it down range, depending on the drag coefficient, a long way, with just a baseball bat. And I thought, okay, if that's the case, that would be quite interesting, because that field, which I was only focused on making that field for the quantum locking and the benefits you would have of not having to deal with G-forces, might also give you a couple of other very interesting benefits. One being a modified or reduced drag coefficient, right? It could also reduce the mass of the craft. And this kind of a light bulb went on, because I had several discussions with Jack Sarfati about this. And he was talking about it. It's a low power, space metric engineering approach. And I thought, what I'm talking about is not high power, right? This would be just hitting with DC, maybe, I don't know, the voltages, but could be in the thousands, or maybe, 10,000 volts, whatever. And then creating this AC ripple over it in let's say the terahertz range or gigahertz range, and getting this effect that you want. And maybe you would have this craft that would have this amazing performance capabilities. You'd have this, you're on vacation from a lot of the physics that would normally affect mass. And this is interesting, if it is nearly massless, then the amount of thrust you would need to propel it at high speeds, whether it be in atmosphere or space or underwater, wherever, wouldn't be a ton of, if it's a low mass. There was a gentleman that posted something today, I think his name is Charlie, on this group. It was about an insects with this hexagonal secondary wing system that they pull up, and that it might have some, I don't know, anti-gravitic effects. And I thought yesterday I was looking at insects, and there was one insect that can jump and exhibit 400 G, 400 Newton, 400 G force. And the scientists were looking at how does it survive that. And one of the things obviously is that it's a low mass insect, and it can do these 400 G jumps. And it got me to thinking, if the craft is low mass, all of a sudden you turn it into a low mass object, you might be able to get away with all types of maneuvers and use very little power to make it move about, as opposed to high power thrusters or rocket motors or whatever you like. Anyway, those are my thoughts. I just want to lay them out there and kind of the journey I went through, and some of the stuff I brought in from the material science world, specifically the group 3,5 nitrides, INGAN, indium gallium nitride, and how that might be applied. There was a gentleman on this call that mentioned, I'm sorry, I don't know your name. You were mentioning some of the stuff just in brief comments before I started talking, and I'd like to hear your thoughts on that. But I don't know your name, but you were talking about some of this stuff. So I'd like just people to chime in and at this point, just tell me what they think of any and all of these thoughts.
Okay. So why don't we do this before we go to questions? Let me put this on gallery view. And everyone, please put your hands together for Steve. And that was one heck of a stream of consciousness. Actually, you went over a bunch of stuff.